Hello, my name is Alexander Brendel. I'm Director Life Science at Infoteam Software. I want to give you a talk and take you along on a trip to digitalization and the Lab 4.0. And I'm trying to show you on a glimpse on how to boost lab effectiveness in already automated labs with a concept we at Infoteam invented and we call customized middleware. But before we dig into those details, I want to give you a short glimpse on who we are and why you should trust us. Infoteam has been founded in 1983 when the world was young and informatics and software development were just on the verge to become important, and no one could see that where this road would lead us to. Nowadays, everything is digital. We are today over 300 people, and we talk the same language as our customers, which is important to us, so we can get you on the road quickly, and we don't do things twice because there were misunderstandings. So to that end, we employ biologists, medical engineers, mathematicians, physicists, and of course computer science engineers to develop the software that will help you in your lab or with your instruments gain the next step. We can do that on a good software development basis according to our certification to 9001, or we can even go into more regulated environments like MDR, IVDR, GMP environments when we apply our 13485 process, our own tailored software development process. We're active in different regions of the market. So for one, there's public service, there's infrastructure, there's industry from where we come from. And I want to lay the focus on life science because that's where we're actually situated today. For the life science business, we do instrument software coming from embedded over connectivity solutions up to middleware solutions that orchestrate different automation islands or in the first place really make them produce and work. So coming to my talk, what are the challenges in today's labs? We live in a world of experience. Facts are fun, but people matter more. Data is everywhere, but no one really knows where it's going to and what it gets collected in the first place for. Automation is on the verge to be established, and there it differs vastly over different labs. Some are quite there yet, some don't even have started, and are thinking about integration and automation and what we call that digitalization of the lab. So it's not about isolated analytics anymore. It's not just having that sample, generating that result, documenting it well, and then go for the next sample, do that for 8 hours, go home. Perhaps it wasn't like that in former times, but today it definitely isn't there anymore. It's all about insights. Insights in a sense of the automation that integrates devices, integrates data and gathers data, and accomplishes workflows over different automation islands ideally. Next is the data analysis, where we use that result data, add and enrich it with process data to come to a point what we call the data consolidation. So we have a more complete view on what happened when we take a look at a specific instrument. Next stage then would be the guidance, to come up with electronic SOPs to integrate or implement an electronic lab notebook or electronic documentation facilities. So that brings us to data enrichment, which even adds more data, more metadata that semantically belongs to that original result we generated in the very first place. Having done all that, we can go into optimization. Optimization in a sense of processes and capacity. So we're able to interpret that data that we collected with the aim to improve our processes, to improve our automation, to improve our data analysis, to improve our guidance mechanisms, and again start over with the optimization. So now you might think it's okay, now today we have some more results and perhaps we have a LIMS and everything should be fine now. Well, actually that's not so much the case, because in most of today's labs, the LIMS is just a data sink where all the data gets carried to on a USB stick by the lab operator. So devices produce results, lab operator carries over, enters into LIMS system. There was a recent study which stated that it was 40 times the same data set gets put into different systems over its lifetime. That can't be the case, actually. And in fact, it's even more complicated. So think about having a middleware in between that already orchestrates those devices, and the LIMS is rather an order processing system than really integrated deep into the automation. But still, even if we have semi-automated processes where a lab operator just orders tasks or gives his validation check, we still have to have some data transfer, and we're not there yet, because what we really want to see is how that works with integrated solutions consisting of different automation islands like research, development, analytics, scale-up, production, quality control, start over again. So again, imagine that as a circle, which get connected by a higher level system depicted here as an ERP, where that data goes in, comes out, and gets consolidated. And then there's the users, the modern users that want to know everything from everywhere at any time, and that want to be able to interact with their systems, with their processes, even over different departments. For example, scale-up needs to know what happened in development, so they can eradicate errors that might come up if they wouldn't know. So how does that leave you when you see that and you imagine how your lab is set up today? Perhaps like this. Yes, stop it, actually. That can't go on. So there's all those instruments nagging, wanting, purging, urging, and you as lab operator, in the midst of it all, you're just reduced to a dispatcher, not the controlling instance anymore that you were in former times. So I think we might all agree that some things will have to change, and rather sooner than later. So the same data that has been put into those systems is the same data that you would have noted on your lab notebook when you were in control. And today, you're just the carrier of data from one instrument to the next system. So how do we want to change that? If we imagine that we have that connecting and connection established, we can talk to instruments, we can gather that data. Again, probably the solution might be software. So to our point of view, naturally, software is key to the success. Before I go into details, let me step one more time back. And let's see if the Lab 4.0, as we see it, is really the same thing that we would do if we redefined it according to the Industry of Things, or the Internet of Things. How to integrate all those actors that are flailing around. So one statement here is that we need to have physical systems, cyber physical systems. Physical systems are the things that move around, that can be touched, tangible things. Cyber is a digital shadow to it, a digital shadow that enables us to depict what is relevant from that physical object to be represented in a virtual space. So objects have a digital shadow then. Information on sample could be stored, the information on an instrument, status, validity, daily maintenance, you name it. And there's an information on those processing stations, which not necessarily might need to be instruments, but could be transporting belts as well. So the idea is that those intelligent objects, and be careful with the word intelligent here, communicate and negotiate. based on given rules, based on their internal states and the idea or the thing they have to fulfill in the end. So what software then provides is a communication network. So those objects and those agents are able to communicate. We have a visualization framework because that's one of the promises of Laboratory 4.0. I can see at any time what happens in my lab. For that, we need that infrastructure, that virtual infrastructure built up and mimicked from the original, from the physical world. We need data aggregation processes and we need tracking and documentation to accomplish all that. So in the end, it's IoT for the lab. IoT being multi-agent systems, so humans, samples, instruments, everything has an agent in that virtual space. And all those agents have an internal state. And that internal state is a who, where, what, when, not to forget the why. Because why is that agent acting as he does? Because he has a goal, he has a priority, and he has some tasks to fulfill before reaching that goal. Again, we need an infrastructure that takes respect on all of those demands, where intelligence is at an actor level. By doing so, robustness increases, because a high-level system failing doesn't mean anything to the agent in another virtual space operating as if there was nothing happening. By doing so, we can decrease costs, because not every system, no monolithic system, has to control everything that is beneath, but there's autonomy in the lower systems. And by doing so, costs obviously decrease, because I can have different separated instances or softwares or systems, call it as you will. By doing so, efficiency increases. But now, how do we get there? Imagining a vast network of different agents that represent different things, from samples of instruments, people, perhaps even departments and buildings. How can we integrate that such that we get different systems working needlessly together without having system breaks in between? There's a twofold answer, and the first part is standardization. We need standards deliberately and definitely to be able to utilize the best-in-breed instruments, not to be locked in with one of the vendors that we just once had, and now everything else would be a real headache to integrate, because we're just sitting on that system, which might be proprietary. We want to share unreduced data freely with others. We want to share that part of the data that is relevant and that we are willing to give away, not everything. We want to control instruments in flexible workflows and achieve repeatable, well-documented results. There's different standards around there, some for data, some for communication. One of the, to my point of view, most emerging ones is Spectaris LATS, based on OPC UA, which combines an agnostic, device-agnostic approach with an industry-proven and established backbone. Second is data consolidation, because once we can talk in a standardized way, not being in Babel, but everyone speaking English, we need to consolidate that data. And that can be seen on two axes. One, intra-level, so on one level of the automation pyramid, we collect that data. We enrich a result with temperature that was in the room when the experiment happened. To accumulate that and to be able to propagate it to the next level. That's what we call horizontal integration. On the other hand, we have vertical integration. Vertical being the packaged data gets transferred to the next level, and by doing so gets condensed. So we don't transport anything or everything that we have on the lowest level to the next level, to the LIMS, to the ERP, to the you name it. But we condense data. And vice versa, we enrich data when it travels from top to down, because the order ID of a test that a LIMS might know has to be enriched for the instrument to know what exact diagnosis or diagnostic test it will have to run with which parameters. That just works if we have enough trust in those standards and in those data transporting mechanisms, that we know that if we have just a condensed set of data in the top, we're always able to go deeper and to dig deeper and to find out what the surrounding parameters at that point in time for that experiment were. That's what we call vertical integration. So how does that help? Assuming we have high quality results, we want to be able to have a high quality of strategic decisions, obviously. Strategic decisions don't really care about all the details it took me to come to a result. But they need the condensed part of it. They need the essence of that information. And by enabling that data transparency and the trust in the traveling of data over different layers of the automation pyramid, we enable strategic decisions that can be taken from all the data that we generated down there. So how does that all help? We eliminate system breaks with standardization, because we have that condensation, the enrichment and the consolidation of data. We can share those over labs, sites, companies, countries. We can have decentralized setups by giving those separation of concerns. Again, for validation in a GMP regulated environment, I will have to care much more about the validity of my data than in an R&D environment where I can at any time, and where I will have to reproduce my data anyhow. We can have reconfiguration through flexible modules, and we implement by design security by need-to-know principles, because when I have confined compartments where I as a user can travel, I see what I am allowed to see, nothing more, nothing less. And that again adds on regulatory conformity when it comes to IVDR, MDR, GMP or FDA requirements. Now zenLAB, the framework, the customized and scalable middleware that infoteam developed as a framework, can help you with that. So our approach is bottom-up, not all in. We're not playing poker here. We have to care for the welfare of our patients. We have to bring the new therapy to the world. So our approach is a customized bottom-up one. What do I understand with that? Customized meaning we touch those points where the pain is greatest first, because that eases us first. We have a modular setup, so we can have targeted changes. We don't have to touch the whole thing if details change, but we target those changes to those modules that are affected or need improvement. We comply with those increasing demands by being able to extend prevalent systems, not have to define everything anew, or you take the new product and throw out the rest, but we set on top of what's already working, and we start to intertwine there and to come up with solutions that really help. And that goes along with changing business needs as well. So again, we just refine relevant modules or develop some new ones to comply with that new demand. What we bring along is a framework with predefined modules. So by not redeveloping and inventing the wheel for the 500th time, we use what's already there and what's most commonly used. And by doing so, we bring along an architecture that's already approved in day-to-day use, and that can significantly reduce those development costs. And by doing so, obviously, we can have a more shorter time to market to comply with. Maintenance will be simplified, and by doing all of that, we have a reduced investment and costs for the life cycle. We gain a scalable setup for life, because with standards compliance given, integration of other devices in the future won't ideally even need a touch to the software. We can guarantee regulatory compliance by already having documented everything according to 13485, or being prepared to go into that documentation process for that specific intended use where zenLAB will be used then. And we can integrate into the existing landscape where we can guarantee extensive to lightweight controlling. So we're just doing parts and we're doing them better, or we take over and we do it right. So zenLAB is a middleware framework for interconnected labs. So the integrated software solution that brings us that one step forward to the Lab 4.0, not the whole road, because no one knows where that's leading to, but the first step that's now to be taken. We implemented those standardized device interfaces, and by doing so we can integrate other software solutions like a CDS, for example, just by design. For device manufacturers, that means that we have a connectivity of devices with zenLAB that is unmet. So we can have different instruments connected to fulfill a shared purpose and to come along with your branding, with your instrumentation design, and give that thing a shorter time to market and eliminate risks, because we can use things from former implementations again if they fit, and we do things anew that don't fit anymore. By doing so, we get a greater flexibility without having to start from scratch all the time. For labs, that means we have a customized middleware with zenLAB where we can immediately start to scale. We provide cure for pressing pain points, and from there we start to optimize and to leverage the whole process you already have to depict better the needs of your operators, the needs of your customers in the end. So we envision 4 stages to the Lab 4.0 with zenLAB as a foundation. The first stage is networking and control. So we have to gather all those instruments, gather those data, consolidate and pre-process where possible and where necessary, and come up with centralized planning and operational plan. The second stage is analysis and visualization of data. So we have those experiment data, we have those process data. We can start with the first data mining and visualize status of instruments, people, experiments, workload, and so on. Third stage is coordination and documentation. So the operational part, to come up with digital standard operating procedures. Ideally, the instrument knows what you have to do next, and you don't have to have that paper next to your screen. And the digital documentation, either for an integrated ELN or for an external ELN. And we have that reliability and efficiency in the 4th stage. So where we come up with an idea how we could optimize that usage, how we could improve our time planning or our fleet management before we then turn again and optimize all our processes that we had before over that continuous improvement cycle. So perhaps that's the idea even for your lab. So you see, there is a way to the Lab 4.0, starting from wherever you are at the moment with zenLAB. And let me thank you for your attention up to now, and be sure to make an appointment at our booth at the Analytica to learn more about what we can do for you and how we could potentially help you with your challenges that are before you. Thanks for your attention.